Hi, I'd like to welcome you to Storage Developer Conference 2020, and I'd like to welcome you to the session, which is Accelerating Swordfish Implementations Using Open Source Tools. My name is Chris Lionetti. So the Swordfish model is actually quite an interesting model. It's not a brand new model developed from scratch. It's actually based on DMTF's Redfish model. The Redfish model has been successfully implemented on every industry server standard out there. These servers have shown the industry how a RESTful interface using HTTPS and JSON can be used to manage everybody's BMCs. So this baseboard management needs to extend into the storage model. The storage model extensions for Swordfish, for instance, is simply an extension to Redfish on using the exact same protocols. So for instance, in Redfish, you would go to a computer system folder, whereas for Swordfish, you're going to go to a storage folder. The differences are very minimal, though. In fact, the chassis is shared. There's a lot of things like disks that are shared as well. So there's a number of things that are shared among these modules. So think of it as an extension, not an entirely new protocol. So there's a number of people developing these protocols. So you can see on the left, the Redfish circle. Those are all the companies that implement Redfish or have worked on the Redfish protocol. And on the right are people that are implementing or working on the Swordfish protocol. You can see there's a number of companies that actually cross over both barriers. So that's the key, is that as we see the industry merging in the sense that we see converged storage, we see a lot of other things happening like that, Swordfish and Redfish need to be the same model, they need to be the same protocol. So in this, we're kind of a little bit future thinking. We're going to cover a number of tools. These tools, I'm going to cover two very deeply. Mostly because I was instrumental in writing them, which is the PowerShell Toolkit and the PowerShell Provider Framework. We're also going to cover slightly the REST API mapping, the emulator, the mockup website. We're also going to cover the basic web client and some really interesting implementations like the Datadog implementation, the Power BI implementation, and there's also a really cool Golang library, which is Swordfish written for the Go language. Again, I love the name. It's called GoFish. So the first thing we're going to cover is the Swordfish mockups. This is probably the first place you want to jump to when you start looking at Swordfish. So a lot of people are unfamiliar or experienced with looking directly at workup specs in XML or in JSON of exactly what these protocols should look like. So in this, what we've done is we've actually shown you what a common implementation might look like. So the Swordfish mockup has got samples of what a implementation could look like. If you were to go and look at the protocol directly without seeing these mockups, you might see 300 fields that all could be filled in without the understanding that it doesn't take nearly that many to actually do a successful implementation. There's a lot of things that may simply not apply to your devices. But again, the mockups are representations of implementations. They're not normative. They don't expose everything we can do. They just expose the most common things. It's good to help you keep from getting overwhelmed. So some of the examples are a mid-range external array, a mid-range array with replication to show how the replication model works, a JBoF attached and Fabric attached NVMe box, because there's a lot of work going on with NVMe and SSDs with the Swordfish model as well. Again, you can navigate these with nothing more than a web browser. So simply go to swordfishmockups.com and select the different system you want. You can actually walk down the tree, and you can see that OData gives you the ability to know exactly what to add to the website. So Swordfish mockups mid-range external, and then /redfish v1. You can see /redfish v1 storage would bring you the storage specifics on that model, whereas chassis would bring you the chassis specifics. You can see you can walk the model very, very easily. So what's in the model? So the model for storage is going to include volumes and pools and groups and consistency groups and system and chassis and endpoints and a whole bunch of other things. Of course, things like volumes and drives and chassis and things like that exist in the Redfish model as well. The difference is, in the Swordfish model, instead of trying to recreate those inside of a Swordfish folder, we go ahead and have pointers to them. So the storage folder might contain links to the different chassis it contains. For instance, if I have a external array and it has 15 chassis because it has 15 different disk shelves, each of those chassis would be listed under Swordfish or Redfish/v1/chassis, and I would have pointers to each one of them. So another tool you can use is the basic web client. So the basic web client gives you the ability to walk down the tree of an actual implementation. So if you have an implementation, you want to walk down it, this is an example of how to do that. So again, this is the web client screen, again, also available on the SNIA website. It lets you walk down. In fact, in here, you can see, if I go under storage services, I've got 3 different storage services that I'm actually managing. So this can handle converged systems as well. It can also be a consolidator for converged systems. I could be handling 15 arrays in here if I had a consolidator. This is very good for converged. Another example implementation is going to be this Swordfish Datadog implementation. So we had one of our members who decided to write a implementation to create a dashboard in Datadog. The nice thing is that once you've written this code once, it should work on every Swordfish implementation out in the market. It's not a matter of having to write it against every API of every array that becomes available to you. At that point, you simply have to ask your vendor, put out a Swordfish implementation of your array, something that responds to Swordfish queries, and then I don't have to rewrite anything as a client. So you can see the draw of the users in this environment. And here's an example of what that client looks like. So again, Datadog is already used to combine information from all over a data center about different things you might want to do in your cloud. Being able to extend this to Swordfish is a really nice trick. Now, we also had the exact same thing for Power BI. Now, these are also great because you can look and see how they did certain things. So you can see how they query and how they find volumes and how they find storage pools. So you can get some really good inspiration from these projects. And again, we don't know what project you're going to come up with, but I can see somebody doing a Grafana implementation as well. Here's an example of what this looks like. So again, I'm managing four different systems. One's a file service, and then I've got 3 different arrays out there, and I can click into each one and go deeper and deeper and deeper. So again, I've got 9 different storage pools. You can see what they're called. So you can make this as deep and as complex as you want, while at the same time being able to expose this across multiple vendors. Now, the question now becomes, how do you implement this? Well, there are 2 different paths. You're either on the client side, and that's to the left of this line, or you're on the provider side. If you have a storage device in the market, your storage device here, that's purple, your storage device here, you want to be able to provide Swordfish to people who are consuming it. So as an example, this is not an exhaustive list of the clients. There's going to be a lot of vendors out here that can talk to your device. So if you have a device, obviously the first thing you want to do is write a Swordfish provider. Well, maybe not. Maybe what you want to do first is actually do a mapping from your device's API, because it's very likely your device has its own API already, and be able to map that to the Swordfish API to see how that would work. Once you get that mapping down, then you could actually create a mockup. Once you get a mockup, you could actually submit that to the Swordfish mockups so that we can actually, in the TWG, review your mockup and actually run it against our tools and tell you where it deviates from the spec. So for instance, when I wrote my mockup, I ended up having the goofiest error where I was using, I had a typo where I had a comma, so it was odata.id, and I was putting odata, ID. And of course, you never see your own mistakes. But since it was code, it was appearing in 500 different places. So once I had my device, and once I did my mapping example, this is where my bug existed, and I submitted the mockup, I created a mockup that submitted it, it was very easy to figure out, oh my goodness, I mistyped here. And I went back to my example and I fixed it. Now this right here is really good if you want to be able to write your own Swordfish provider. So this is great first step to make sure you're getting the protocol right before you go ahead and commit code time to it. Again, if you want to be able to test a certain client against it, you can take the rest of Swordfish map API and go right to a Swordfish provider example. And I've got one that's in GitHub right now as open source. So again, you can make a Swordfish provider that will let you respond to different management tasks through the REST API to Swordfish map directly to your storage device. So without changing your device in any way whatsoever, no firmware update, no OS update, you could actually be talking Swordfish through a proxy. We also have the exact same thing in Python. And we have a Redfish server that's available in Python today that you could actually modify and add Swordfish implementation to, and actually make it into a Swordfish proxy agent today. So there's a number of different paths you can go down. You could also, if you don't want to start with a storage system, if you want to start with the client side, your management software can be written so it talks to any of these. But the nice thing is if you don't have a storage device to talk to and you kind of want to just test out your storage management software, you could actually take our emulator and start adding things to it. Add drives, add chassis, add volumes, just to see where your storage management picks it up. So again, there's a number of tools out here to make your life a little easier. I've also written the Swordfish PowerShell Toolkit, which queries Swordfish devices and brings back all the objects for you. Now we're going to use that as well to write a Windows Admin Center extension so that you can actually manage Swordfish devices directly from Windows Admin Center. So again, the clients are only half the story. The server, the providers are the other half. And there's a bunch of different paths you can go down to make your life easy. But again, the technical working group for Swordfish is all about helping people out. If you submit a mock-up, we can go through the mock-up and actually help you to make sure you're protocol compliant. Now let's talk about the mock-up, or let's talk about the toolkit, one of the clients. So in the toolkit, here's an example of where you can download the toolkit. It's all open source. And it supports PowerShell on Windows Server, Linux, and Mac OS. And basically, it's just an API wrapper for the Redfish and Swordfish calls. So the first thing you do is you import the module. You connect to your target, and again, you can see I connect to a target with a certain IP address and a certain port name. Once you've connected to that target, it returns back the object of what that target returns. So if I were to open a Chrome browser directly to this address, I would see this come over in the screen as well, because Chrome can actually talk JSON. It will show the JSON material as well. But you see, this is a PowerShell object. It's not a JSON object. I'll show you how to fix that in a minute. And you can see that not only can I talk to the Swordfish target, I can also talk directly to the mockup. So if I want to test a certain command against the mockups, I can do that as well. Now in PowerShell, there's a couple things to know. $myvols is a collection of my volumes, and I populate that by using get swordfish volume. You can see that I always put the verb swordfish, and that's that I don't have collisions with PowerShell commands that exist inside the OS today. If I just simply use get volume as my command, there's already a get volume command, but by putting swordfish in there, I never had that problem. So these work as verb dash swordfish noun. So get swordfish volume. You can see it's pretty easy to predict. Get swordfish chassis. It would be another one. Get swordfish pool. Get swordfish group. There's a lot of different commands that fall under this. Now, when I get this volume, it's actually a collection. That collection, if I want the fourth member, I simply type myvols square bracket 4, and it returns just the fourth volume. Or I can do filters where I pipe that to where the previous object, myvols.name is equal to volume 5. I could also dig deeper into single values. So if I want the the dot status of volume 4, I can get it right there. If I want the size, I can put dot size after here. Any of the different JSON key names can be put here, and it will return back the data. Now you can also take any of these objects and cast them right back into JSON format, simply by taking that object, like myvols4, pipe it to convert to JSON. And now it puts back JSON native code. So that puts on screen exactly what the JSON for that volume looks like. And if I did myvolumes4 dot name, it would come out volume 5. If I dot ID, it would come out 5. If I did dot identifiers, it would return this object right here in a little table. You saw when I did dot status, it was actually returning this. State enabled, health okay. So again, that's how the PowerShell Toolkit returns objects. Now, help. A lot of times you're not going to know how to run the command. So basically, get command module help gives you a list of all the commands. If you do a get help and then the name of a command, you get the basic man page for it, manual page. If you do dash examples or dash full, you get different screens showing different objects. If you do, we don't check anything into the PowerShell toolkit that doesn't have full help developed and also examples of how to use each command. I've also added one other thing, which is verbose true. If you do verbose true, you'll see the raw transactions that go from the PowerShell toolkit directly to the device, and then the raw transactions come back in JSON format on screen. So that way you can actually see exactly what's happening before we turn it into a PowerShell object. So here's what the helps look like. And again, everything's laid out, the synopsis, syntax, the parameters, how, what they expect, that kind of thing. I should note that there's a number of commands that have already been implemented. Chassis, chassis power, chassis thermal, drive, endpoint group, storage pool, volumes, and I also have two commands for connect to a Swordfish target and connect to the mockups. And again, the target could either be a PowerShell provider, a Redfish emulator, or an actual real target. I should note, though, that the REST API and PowerShell work a little differently, and that is that the verbs are different. Create is the same as new. Read is the same as get. So this right here, get Swordfish drive, is a REST API get read command. But it's no different. It's the exact same thing with just changing the name of the verb at the beginning. And again, everything is open source. Everything is human readable. Now let's show you what the mapping looks like. So in here, if I have a REST API documentation to my target, and then I have a PowerShell toolkit for my device that exposes the REST API returns and a little knowledge, and if I have access to the Swordfish mockup and the Swordfish specs, I can actually have everything I need to build an implementation that's a proxy. So the first thing you want to do is you want to go ahead and get the volume object from your device as an example and expand its JSON and hold it side by side with the volume object from the Swordfish mockup site, just to see what matches up and what kind of things you want to implement. Now, once you've implemented some basic things, you can then go through the spec and see what else you might want to implement. I'll show you an example. And also you're going to need to normalize your data. For instance, on my device, I have a cache policy setting. And again, my API calls it cache_policy, and it returns either normal or off. So if it returns normal, I want to use the Swordfish named options, because normal isn't an option that Swordfish uses. In Swordfish, you have to describe it, adaptive read ahead, or off. And there's a few other options as well, but my array doesn't do those options. So I only have to care about these two. But you see, I'm actually taking and making a new variable so that I can actually put the right thing into Swordfish. I may also have to do the same thing for volume sizes. If my device, device responds in kilobytes and Swordfish expects bytes, I need to know to multiply my result by 1024 before I populate Redfish. And let me show you what that looks like. So here on the left is my get volume for a certain volume converted to JSON, so you can see all the different fields. Now, a lot of these fields are simply never going to map over. But you can see other ones, like my block size, is going to map over directly. But on the left, my field under my API is called base snap or block_size. But on the right, it's block size bytes. Notice the capitalizations as well. I want to get that right too. You'll notice on the left, online is equal true. Here, it's going to be status, state health, okay, state enabled. So there's certain things I'm going to go ahead and populate on the other side, depending on what I find on the left, as to what I find on the right. There's going to be other fields that I'm going to hard code. For instance, my array may only happen to support triple parity RAID. That's it. That's all we do. So in that case, when it goes to RAID type, I might want to hard code in triple parity RAID. As an example, here's what that looks like. If I'm using, and by the way, I have a mock-up project out there that takes and creates a mock-up for your system. Well, it does for my system because my API is written into it. But you could easily pull my API out and put your API in. But you can see that everything in brown is hard-coded. Manufacturer, I've hard-coded the manufacturer in because it's my provider. I've also done encryption type. The only type of encryption we do is controller assisted. So I'm able to hard code that in. But under deduplicated, and by the way, that's the way that Swordfish wants to see it, is deduplicated, I simply feed in the same value for my volume, dedupe enabled, because my REST API calls it dedupe underscore enabled. So you can see I've actually converted a lot of these things over. And again, once you've looked at, and again, you don't have to start big. Start with about what you see in the mockups, and then start adding to it the things from the protocol that you see could be added. Now, I should note, the only thing weird here is that I've had to add quotes around these guys, single quotes, because the @ and the dot sign can't be used in a key name unless you escape it first. So here's a provider example. I wrote one, it's called the Swordfish Mockup. This is actually a provider. I originally wrote it as a mockup creator because it would query the array and find out everything about the array and save it out to a file system, a zip file that I could then submit. And when I say submit, I submit it to the technical working group where they can run it through a tester that can actually respond and say what's out of spec, what's in spec. And it's actually helped me a lot. It's found a lot of errors I've had. And little things too, like odata.id. I had fat fingered it and put odata comma ID, and of course you never see your own mistakes. So I had to, and of course once you put it in code, it happens in 1,000 places. So I had a whole bunch of errors pop up, and then I fixed one piece of my code, and all of those went away. So it's actually kind of nice to have the mockup tested for you, and it acts as a static reference as well. Now I should note in this is called a hidden command called listener. If you run listener, it will actually act as a Swordfish proxy agent. So now my Swordfish mockup acts as a proxy agent. I can connect to the system and actually talk directly to my array and query information directly from the array. So this lets me do things like, for instance, if instead of actually creating a mockup and hand coding all this stuff to simulate 7 volumes, I simply might go to my array, create 7 volumes, run the listener, and then I can actually pull the mockup and it's created for me. So you can see it makes life a lot easier. And again, it's all written and commented out as well. So if you read this open source project, you'll find all the comments of exactly what to do to be able to take my API out and put your API in to do the exact same thing. Now I should note that one of the difficult conversations I've had in the past few years is what arrays natively come out with an API that's Swordfish today. And unfortunately, up till now, there hasn't been one. We've got a number of customers, developers that have betas, proxy betas, myself being one of them, but nothing that's released to the public yet. So September 8th of 2020, we just released the HPE MSA2060 Gen 6. It is the first product on the market that natively supports Redfish Swordfish on the device. And again, this deck is going to be updated over time. If we give it a similar deck next year, I would love to add more vendors. I'd love to add you if you're a developer that actually has a device that you want to make Swordfish compatible. So again, work on these Swordfish implementations. By this time next year, we could have a much larger list here. So there's a bunch of places you can find information. You can go to SNIA.org/swordfish, and you're going to find user's guide, practical guides, other documentation. Take a look at the mockup sites. And again, don't start big, start small. Do very, very small things like a minimal implementation just to get your feet wet, and then start slowly adding to it. And you're going to find that it's very easy to add 1 or 2 or 3 things at a time to an existing implementation, as opposed to then trying to boil the ocean, as it were. You can take iterative steps to be able to do this. I also urge you to join the SSM Twig, because that's where we talk about these things. And more importantly, if you have an implementation and you're unsure of how your stuff maps to it, that means we need to have better documentation as to how to do that. More importantly, if you have something in your array that isn't able to be implemented in this protocol, we want to hear about that. We want to be able to make sure that this protocol does cover those cases and how you would implement it and document how that happens. Because the last thing in the world we want is this protocol not to be indicative of what's in the industry. So please help us out on that. I think we've done a pretty good job right now of making sure that the protocol matches what's actually available out there. But again, there's a lot of ingenious developers out there doing a lot of interesting things. Come to us, help us help you make your stuff industry standard. Again, submit to the Swordfish forum your mock-ups. We would love to see them. We'd love to help you with them. And we'd love to hear where you've run into problems where they don't match up. Again, it may be a documentation problem. Everything is done on GitHub as well. The entire protocol development is done on GitHub. So you can actually open an issue on GitHub saying, I don't see how this protocol piece works here because of the way we implement it isn't covered. And that will be handled on the GitHub site, all in public. So we'll make sure that gets covered and other vendors get to come in and say, yeah, we're looking at the exact same problem. So please, again, also, if you're interested, we would love to see more integration points. More projects like the Datadog or the Power BI or GoFish. Those are great little projects. I would love to see a Grafana project. But again, you guys are ingenious groups. You guys can come up with some really interesting stuff out there. And that's pretty much covers my session. If there's any questions, I believe there's going to be some Slack channels for Storage Developer Conference that are going to be monitored. The nice thing about that is you're going to have all the Swordfish experts available on those. So even if I can't answer a question about this, you're going to find other speakers that can. I also urge you to take a look at the other sessions. This session was specifically not about going deep into the Swordfish model. It was about the tools. There's some other sessions that go much more into the models, and I urge you to go take a look at those. You're going to find about 4 or 5 really good sessions with very experienced speakers. And again, please take time to read the sessions. The feedback matters. Being a virtual event, people kind of look past that, but we want to make sure that we please you guys and that we do proper sessions for you guys in the future. Thank you for your time, and have a great day.